All right, so not because you have to, but if we're talking about strategy and trying to minimize the odds of making a mistake. Oh yeah, she needs it. Is he your pencil dealer? What would be the best method here?
Elimination.
I agree with elimination. Why elimination?
Because it's the relative standard.
Both equations are in standard form, but sadly, I do not have a coefficient that matches. So we're gonna have to make one of them match. But again, if not because we have to, but if what we're trying to do is minimize the probability of making a mistake. See, because this is not the first year that I teach this stuff, right? So like next unit, which is I'll be starting next week, but then mostly when we come back from break and we get into factoring, yeah, if you start telling me that you're struggling with factoring, it's okay, I get it. Like I get it. You know, that's universally known as the most challenging topic in Algebra 1. But for systems of equations, this is not widely known as something kids struggle with. Usually, if you pay attention and try, you understand systems. But that doesn't mean that you're impervious to mistakes. Like it's possible that you could still screw up. So like the more steps you try to do, the less likely, like the more likely you are to make a mistake. So all right, that's what I'm trying to get at is what would probably be the best variable to eliminate if you're trying to minimize the chances of making a mistake? Yeah. I wouldn't go with the x. Doesn't matter. The fact is, all right, fine. If we were to do what Elsie said, and you can, I could get rid of x and I would get it right. I wouldn't make a mistake because I'm awesome. But if we were to do it your way, what would not -3. But if we choose to get rid of the y's, what would we multiply by? 4. So the point I'm making is, do you think more people are likely to make a mistake when they're multiplying by a negative or multiplying by a positive?
No, negative.
Yeah, yeah. I think you'd be more likely to make a mistake with a negative. But if you just for fun as a social experiment, if you want, you get rid of the x's first. I'll get rid of the y's first, and you'll see that we still should end up with the same thing. So I'm gonna get rid of the y's. I'm gonna go multiply times 4 on the bottom. The top equation stays the same. Now I'm ready to eliminate the y's. But when you eliminate, what operation are we doing? That way you can do the retake. What? Yeah, we're gonna add. 7x is equal to. Did you see your grade? Yeah, so you should probably write this down then. You know what they say about old habits. Now the way that this is not the way the test is going to be tomorrow, but the way this particular practice test was structured is for these types of for these types of problems where you actually had to find the coordinates, you got like each individual coordinate counted as its own question. Which, by the way, it was there was not one question, one coordinate. There's not one of anything that more than half the people got right. I think the highest percent out of anything was like 39% on any one. So it was pretty bad. Some of the people saw the how drastic the curve was. That's part of the reason because the average was so low. So that's what allows somebody that has so high. So anyway, so I now know that x is -4. I need to go substitute into either equation. I would think most people here would pick the bottom one. So -4 plus y equal to -1 plus 4 plus 4 y is equal to 3. On tomorrow's test, these problems will show up as ordered pairs. So what would this look like as an ordered pair? How's your calculator, Isaac? Charged? Helps. Are you like in your LTC mode or something? You have like a serious face. If you're like standing at attention and you smile or something, do you get in trouble? Yeah.
Right? Like if they're in my face yelling, I would just start laughing.
Well, we don't want that. No physical activity here. What would be the best method for this one? Yeah, elimination also. We can get rid of whichever variable, just like the last one, but unlike the last one here, the signs aren't really leading me to any one particular variable. Both of the x's are positive, both of the y's are negative, so you can just randomly pick. Jonathan, you like randomly picking things, so which one would you like to get rid of? Okay, whatever Lana says. So if you want to get rid of the x's, what number would you have to multiply by? Very good. So multiply her thing by -6. -6 x plus 6y is equal to 36. 6x minus 3y is equal to -9. Well, don't say subtract. I mean, really what we're doing is adding. This is elimination by addition. But yes, when you add a negative, it's the same as subtracting. So 6 minus 3 is 3y. That's 27. All the children rejoice when they find out y was negative. Now you need to find the x. I would think most people would pick the top one, but you can pick whichever one you want. So x minus 9 would be the same thing as saying, sorry, x minus y would be the same thing as saying x minus 9. And that's going to be equal to -6. Plus 9 plus 9, x is equal to 3. So, what would be the ordered pair that goes with this? Like if I were to draw those two lines, where would they cross? Yeah, make sure the x comes first. 3, 5, 9. If you're not sure what the order is, what did I tell you? What does the order mean in ordered pair? Alphabetical order, yeah. Alphabetical. Orden alfabético. There's no such thing as common sense. No sense is common. No. Common applies that common means that it's widespread. That many people. No, that's it. That's not the case. What would be the best method here? I agree, but geez, why would this be one of the ones that people miss the most, right? Because it seems pretty simple, and I think by the time we're done, you're going to agree it's pretty simple. But what do you think people might have been confused about?
They might have done elimination.
No, I don't think so. Well, see, the thing is, we're used to substitution when one variable is solved for, but here, two variables are solved for. But if anything, I would argue that makes it easier. Because really, like, no matter what variable you choose to substitute, you're going to end up with the same thing. If I get this x plus 6 and put it in for this y, or whether I get this 2x and put it in for this y, I'm still going to end up with an equal sign, an x plus 6 on one side and a 2x on the other side. It's the only thing you could end up with. Yeah, you might have the 2x on the left and the x plus 6 on the right, but it does not matter, man. And what would be the quickest way to solve for x here? If I wanted to isolate the x, what would be the quickest way to do it in one shot? Definitely don't want to divide. There's two. I definitely would not do that either. I would not subtract either. Because I have.
I know.
Nope.
I know what it is.
Go, Elsie, go.
Subtract x.
Subtract the order.
Yes. Oh, cool. I heard, is that, sorry, I'm not very
And this is, if you're paying attention now, this is a perfect example for me to illustrate what I've been stressing to you, and you guys are probably a little bit like, I don't know if he's right. You're maybe doubting me about the fact that you can plug it into whichever equation you want, because you can do. You guys should all be able to do this in your head. What's 6 plus 6? What's 2 times 6? Still 12, regardless of which equation you pick. Still end up with 12. Sarah, what ordered pair would these two lines cross at? Shh, Sarah. Jonathan, stop tripping. Tough one. Would you like me to sing the ABCs for you? Do you know that the ABC song is set to the tune of Twinkle Twinkle Little Star? Bet you didn't know that.
Oh my god, it is! Whoa.
And they say that you don't learn things in public school. Mind blown.
Okay.
Now you gotta pay attention.
Set as
Thank you, Jonathan. It is 6, 12. No, it's not Mary Had a Little Lamb. No. X comes before Y, so 6, 12. Fax machine. That's gonna stay with you all day, huh? You're always gonna remember where you were when you learned. Now, this is probably, out of all the ones we're going to go over today, yeah, well, I don't know. This would be the one that I just cannot fathom how it was missed so much.
You can just start with elimination. It's so easy.
Yeah, not only would we do elimination, out of all of these, I believe this is the only one where I can already eliminate right off the get, as the cool can say, from the get. So then Jerry Berry, he wants to add everywhere, so he says 6y is equal to 18. So then divide by 6, and we know that y is 3. But that's only half the battle. Yes. Oh wait, I'm sorry. Thank you. I didn't see the negative. Thank you. Appreciate it. Yeah, I'm sorry. The 4 was negative, so there should be negative 2y. Sorry about that. Did I confuse anybody there? So then now, can I get the negative 9 and plug it in for either of the y's? It doesn't matter which one. We'll just assume that you pick the top one. So 3x minus 4 times negative 9 is equal to 9. So I like to multiply. Negative times negative is positive. Minus 36. So 3x is equal to negative 27 divided by 3. Not only was y negative 9, x also ended up being negative 9 as well. Amici, yo no sé. Negative 9. So like if you were to do the retake because you didn't like your grade the first time around. Oh, it's just easy to look in this direction. I can look at 7. Can we look at Nico? You got a 7 on the test?
No, I didn't.
They be tripping too.
Only practice.
Get those mistakes all out of the way. What would be that? Like this one here out of all of them, I don't want to say it's hard, but it's probably the one where the most work is required. I would hope you see its elimination because they're both in standard form, but there isn't one variable that really stands out as being easier to eliminate. So it's just a matter of, do you feel more confident that you know the least common multiple of 5 and 8, or do you feel more confident that you know the least common multiple of 7 and 6? Yeah, Jane Dizzle.
You multiply the 5 by 8 and you, or negative 8, and you multiply the 8 by 5.
Well, I'm just looking for least common multiples. Like, what is the least common multiple of 5 and 8? 40. What's the least common multiple of 6 and 7?
30.
42. And a neighbor. So just pick one. I'll just assume most people pick the x's. So I will multiply the top by 8 and the bottom by 5. But wait, Mr. Romero, that's wrong.
Wait, what?
If I only multiply the top by 8 and the bottom by 5, what's going to still be wrong? No, not everything. No, the signs. I'm trying to get rid of the x's, but they're going to both be positive. So you pick one and make them negative. Jason, which one did you say to make negative? Okay, so Jason said the top one, I'm going to make the bottom one negative, just to show him his boss. Yeah. So I'm going to make the 5 negative. So the top will become 40x plus 56y is equal to 256. Bottom is negative 40x minus 20y equal to negative 230. Hope, have you gone back and listened to any other videos to see if it sounds better? Have you eaten cereal in class? How is it? What type of cereal is it? It looks like Lucky Charms.
Like Cheerios.
You don't know, it's marshmallow delicious. The marshmallows are good. The other ones make me want to throw up in my mouth.
I only like Cheerios.
You know that tricks are for kids. I don't know. Yeah, I don't know. It's just baby. I like cinnamon toast crunch.
That makes sense.
What? Well, it's not 26 equals 26. What it is 26y is equal to 26. It does matter because if it was only 26 equals 26, that would be infinite solutions. But this is just going to be y equals 1.
Y equals 1.
And then now that I know that, I can go to whichever one I want. I'll just use the top one again, doesn't matter. 5x plus 7 times 1 is equal to 32. 5x plus 7 is 32. Minus 7 minus 7. 5x is 25. 5 by 5. X is 5. So, John, what would this be as an ordered pair?
Can't recycle plastic glass anymore.
What? 5, 5?
25.
5, 1. Y was 1. I even color coded it for you. Let me see.
not. You put that in a store, you don't ever disrespect coffee like that.
Coffee is simple.
Okay, what would be the best method for this one? Elimination's good, but, 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 are any of these variables ready to be eliminated?
Yeah.
Why not?
Oh.
Yeah. So it looks like the y's are ready, but they're not because I need to change the signs. So what can I multiply by if all I want to do is change signs?
3.
Heck no.
Negative
A -1. Now, if you were to multiply the top by 3, you could get rid of the x's. That's fine. It's not that it's wrong. I didn't say not to. I didn't say not to. I just said if you. But that's the whole purpose. I prefaced back at the beginning of the unit. I gave you that long story about the girl who only knew substitution and never learned elimination and still got everything right. And that whole purpose of that story was not to confuse you, to show you that things can be done more than one way. Okay, so yeah. But look. Fine. I like the fact that you're thinking, and part of this is opinion. Part of this is opinion. Somebody might say, I love negatives. You know, my favorite thing to multiply by is a negative. But see, in this one here, in the first one that you're comparing it to, my options were either multiplying by a -3 or a +4. So there wasn't just the fact of a negative or positive, but like the negative had another number attached to it. Like I had a 3, it was a -3. So my argument was, well, if you're going to do that, I might as well multiply by 4. Now, here, I'm advocating multiplying by -1. All that should happen is the signs change. So, but I mean, it's, what do they say, 6 of one and half a dozen of the other? It's, you say tomato, I say tomato. Even though I've never actually met somebody that says tomato.
Oh, my grandma does.
That's not true. Maybe Lana says it because she speaks German.
I speak
Tomato. You say tomato.
Like the, yeah, tomato.
So all I did was I changed all the signs on the bottom. But again, Elsie, please tell me you're not confused. If you wanted to multiply the top by 3, go for it. It's just you're going to be getting rid of the x's, not the y's. I'll get rid of the y's. So 4x is equal to 4 divided by 4. So x is 1. Now that I know that x is 1, pick any equation you want. I guess most of you would pick this one and say 1 minus 2y equals -5. 1 minus 2y is equal to -5. Each time you substitute, how many variables should I see?
1.
Yeah, now there can be more than one of it, but there should only be one type of variable. Right? I mean, see, yo no sé. She said yo no sé. No sé. Divide by -2. All the children rejoice when y was 3. Jono, you go up a little bit. What's the ordered pair here for this? 3, 1. It's only Lana could be there if I'll be over tomorrow. You're not gonna be here tomorrow, Lana? Who's the one? Oh, it was last period. Man, I forgot to check with her. That was this period. Did you go learn what the Florida Panhandle was? Still never heard of the Panhandle. They also call it East Alabama. What Sarah! No. What method should we use here? Yeah, I like substitution here because the y is isolated, so I get this x plus 3 and I plug it into the other y. So 8x minus 7 times x plus 3 is equal to 12. How many variables do I have left?
One.
Yeah, just the x's. I know there's two of them, but we're not scared of no x's. 8x minus 7x minus 21 is equal to 12. This works out nicely. Jono, what's 8x minus 7x? Your fingers. 8 minus 7.
Oh. That's plus 7.
I thought you were joking around, so I was kind of going along with the joking stuff. But no, it's okay. Oh, classic Johnny. All right, so x is 33. The nice thing about substitution is that there's usually one equation at the end that's a little more friendly than the other one. That's also the case here. Inoshka, 33 más 3. ¿30 qué? Gracias, muy amable. Darío, what would be the ordered pair here for the solution? Buen hecho, señor. What color is Jimin? The gym? I don't even know if it had, like, the gym is like. Yeah. So, I don't know what building letter that is, but it's like. There's a big gym downstairs, and then there's like a littler gym upstairs. All right. So even though you can't see it here, this was the first of 4 different problems where you were not being asked what the specific solution was. You were just being asked if there was a solution. Someone last period goes, "Yeah, mister, you tried to trick us by putting 2 solutions in there." To which my reply was, if the fact that 2 solutions being an option there tricked you, I think the issue is more with you than with me, because we know that straight, like, that's why we started with graphing, because if you have 2 straight lines, once they cross once, if they were to somehow cross again, then they wouldn't be straight lines anymore. Anywho, yeah, we should know all of these are. There's only really 3 options: either one solution, no solution, or infinite solutions. So let's see, what would be the best method here for solving?
Elimination.
Okay. Now we have to pick a variable to eliminate. You're gonna pick that up, right? Whatever you just threw in the air, you're gonna pick up. He flicked something up in the air.
Okay.
Which one do you want to get rid of?
Let's do the top one.
No, it's not top one. You want to get rid of the y's or the x's?
The x's.
Okay, so if you get rid of the x's, you multiply by -3. I'll let you know a little hint. If you would have picked the y's, we would multiply by the same thing, because look at what's going to happen. What's going to happen? You're going to get -3y plus 15x is equal to 18. On the bottom, you get 3y minus 15x is equal to -12. Uh-oh. Things be happening. Look, Nico. We wanted to cancel the x's because that's what Emma wanted. Yeah. But by mistake, the y is also canceled. So what's left on the left? It's hard because, like, when nothing is there, if only there was a number that represented nothingness. Then, yeah, 0. to negative 6. Is 0 equal to negative 6?
No.
So because there's no more variables and because this is not true, this would have no solvation. This one was like you would think those 4 would have been the easiest ones you had yesterday, but all 4 of those fell into the category of most frequently missed. And yes, there were multiple people that put 2 solutions. All right, somebody not named Emma Grace, tell me what would be the best method here. You're not Elsie Grace. Lies. Lies, all lies. Maybe I haven't heard from you today. What would be the best method here? Okay, what variable would you like to eliminate, maybe? It's not a variable. Do you want to eliminate the x's or the y's? Okay, if you want to get rid of the x's, then what you could be multiplying is by negative 3 to the top. And look, crazy things be happening. Negative 3x plus 6y is equal to negative 18. 3x minus 6y is equal to positive 18. Nico, watch this. It's time to use my ninja focus.
Oh, so 0 equals 0.
That is correct. 0 does equal 0 in it, and there's no more variables, so we know that there can't be one solution. I would hope you would already know that there could never be 2 solutions. So how many solutions are here? Infinite.
Oh, infinite, that's beautiful. That's beautiful.
Why infinite solutions? Why infinite solutions?
Because 0 equals 0.
Because that's a true statement. 0 is equal to 0. If you have 2 numbers that are equal, then. What would be the best method for this one? Substitution. We get this value for x and plug it into the other x. So 2 times negative 4y plus 4 plus an extra 8y is equal to 8. I only see y's, and I really, really, really want to try my best to solve for y, but it's spaghettios. The x's had already canceled due to the substitution, but now in an attempt to solve, the y's also canceled. But then Nico noticed that 8 is indeed equal to 8, so therefore, this is hurting your brain for real.
Yeah, because there's so many 8s. My dyslexia is like, so it's just not working.
There's an infinite amount of 8s.
No, there's not.
Thanks, man.
So are you writing all this down? What would be the best method for this one? What would be the best method for this one? I like substitution. Get this value for y, plug it into the other y. So 3 times 6x plus 2 minus 18x is equal to 12. You didn't go already for the next one? 18x plus 6 is minus 18x equals 12. Oh, oopsie daisy, the x is canceled out. There's no variable left. Drop the positive 6, drop the 12, is 6 equals 12? So there is no solution. And then finally the last one, graph. I find this one kind of interesting because if you really, I know it was a while ago, but if you really pay, yeah, why not? we have two equations. As far as graphing, using graphing terminology, what form are those equations in? Uh-huh. Slope-intercept. They're both in slope-intercept form, right? Which, if you remember back in graphing, you had been asked to put things in slope-intercept form because before we even graph, there was a way to check to see what type of solution we were going to get. What did we look at when it came to graphing to determine the type of solution?
Oh, the lines and like they're intersecting or if they're like.
Before we graph, before there was ever a graph on the paper, I showed you how to look at the equations and determine the type of solution before pencil met paper. If only there was like these notes that we kept in a central location that the teacher.
Wait, I got it. Let me find it.
A plane crashed on the border of the United States and Mexico.
Wait.
Right on the border. Where do you bury the survivors?
Yeah, I would probably bury them. They were, you know.
Wait,
It depends on which side they were from. They're from the west side.
Right on the border?
Wait, how would you rate the survivors?
Oh, that's true.
I didn't even think about that.
Y'all really tripping.
Just close the answer.
No.
I mean, tell us what it is.
No, we got time, so you guys can go look through the
I
notes.
looked at my notes, I can't find it.
You can look at the notes for graphing, the one packet that I printed out for you, and it told you it's the one that says graphing on it.
We also didn't.
Well, it does have something to do with y-intercept. It also has something to do with slope, hence why we just finished saying put them in
Well, graphing. Oh.
graphing systems of equations. Solving systems of equations by graphing.
So, negative 2. Any colors in the graph?
No. The equations are already in the form that we want them to be. We want them to both be in solving systems of equations by graphing. No. Close.
Slope is 2/4.
Study. Hey, look. On Tuesday, March 12th, we learned how to solve systems of equations by graphing. Oh, was that the? Oh, you know what? Was that the day? Yeah, that's right. That was the day where because of testing, I didn't see you. So I told you guys. I actually did print this out and give this to you. No, I printed this out and gave it to you. I gave it to you when you came back. So and here's where like all that information is that you would need. But I also did tell you to go online and watch this. So let's see.
I didn't watch it. I don't remember. Was I here? I found it in there.
Before. Look, before. In order for there to be one intersection, one solution, what would need to be true when you're graphing? Different slopes.
No, it's not true. Yeah, right. This is one of the most honest
I hate my voice.
No,
10 minutes. So now let's go back here. If we're just trying to pick the right answer, that's why it's amazing to me that this would have been one of the ones missed the most. What's the slope of the first equation? 2. That's fine. That's fine. Just leave it as 2. Yeah. First one is 2. What's the y-intercept?
1.
What's the slope of the second equation? 1. What's the y-intercept? So before we even graph, we can already tell how many solutions are we going to have? How many solutions? Solutions mean intersection. We're going to have one. Why do we know we're going to have one solution? Do I need to play the video for you again? They have different slopes. If the slopes are different, who cares about the y-intercept? The slopes are different. I have to have one solution. So I know it can't be no solution. I know it can't be infinitely many. Now, if you actually went ahead and tried to, yeah, I know it's kind of hard on the computer and stuff. Tomorrow it'll be paper and pencil. Maybe it'll be a little easier. But the thing is, option A and option D, the graph is exactly the same. So the only difference, and maybe, see, like if this is why you missed it because it threw you off, I can at least get it. But this is another reason I had a bunch of people putting B and C also. The graphs are identical. So the only difference between the two is that point at -5, -3, or is that point of intersection at -3, -5? Yeah, it's at -3, -5. So that was it. All right, any other questions for me, Hope? Sarah?